I'd like to thank Total Element Magnet Supplier for sponsoring this video. These guys are at least 10% less than the other big name magnet providers. And if you use the link in the description and the code 3DPPM, you'll get an additional 10% off your magnet purchase, as well as any magnet accessories like the magnet splitter. All right, guys, so welcome back. So I have a new project that I'm going to do. And it's going to involve this little weird type rotor. This guy goes like this. It gets screwed together, and of course, the magnets I'm going to use are going to be different. They're going to be sphere magnets. Now, when I first made these guys, I thought, I did it, and they seemed to be kind of too close together, but I'm still going to try it. But the magnets that I'm using are from Total Element, and I want to thank those guys again for providing and sponsoring another video. Here's the magnets that they provided, and they come shipped really well. They come shipped in these red kind of casings on it. Oh, that's the wrong one. I have one that already has one of the shells on there. I didn't want to take that one out. These are 1-inch N52 sphere magnets. Really nice, really heavy too. And what was funny was I did some research on getting these, and I checked out several other well-known magnet suppliers, or magnet, not suppliers, but people who sell magnets, because I think Total Element's one of the few actual supplier of magnets where you can get a large quantity. But every single other site that I checked, and I checked 4 other ones of the main, the other 4 really big magnet providers, and Total Element was the only one that sold a 1-inch sphere magnet in N52 rating. All the other ones, the highest they would go is N42. And N42 is okay, but I want an N52. I want the most bang for the buck you can get with these guys. Anyway, take it back out again. Show you what it's kind of going to be like. So these guys will go in here like this. This guy will go on here like that. And I did screw holes there, so I could put a screw through there, and it goes into a smaller hole on this side. And so, yeah, I'm going to do it like that. And I'm going to try it a couple of ways. The first way I'm going to do it would be the obvious way of finding out where the dividing line is for these sphere magnets. I got to get this apart. And then, come on. There we go. Find out the dividing line, and I've got, here it is. I've got my magnetic film, and there you can see, I don't know if you guys can see that, there's the dividing line right there. So that would be north, that would be south, or vice versa. And I'll actually put these in here like that. So north, south, north, south. That's how I usually do my rotors. And they should work great. I've never made a rotor using sphere magnets before, ever. I never even thought of it. And I started thinking about, well, I gotta, I want to make another rotor setup, and I want to use these guys again. I want to work with Total Element. And so I went on their website, and sure enough, they had the N52s, 1-inch sphere magnets, and they come packaged really nice, of course, with all the foam and all that good stuff. But they're the only ones that I ever see ship with these plastic containers like this. I got my 1-inch cube magnets in the same type of container. Anyway, I made a second set with the arms farther apart. I made these out of PET G. This is just made out of regular PLA. I printed these both on the Bamboo Lab. The last time I used this PET G, it was wet. And so I think I have a Sunlu dryer. And I used it, tried it, and man, it came out gorgeous, as you can see. Really nice. But I'd rather do my rotors now in PETG. But I have plenty of rotors that I've done in PLA. So I'll try this one. I don't think it's going to work because I think they're too close together. But we're going to give it a shot anyway. I'm going to set it up probably in this guy right here. In this rotor right here. There's my PCB way clear plastic rotor. This is the same one up here from PCB way. Anyway, thank you, Total Element. I'm going to get this guy going, and we'll see what we can see. Stay tuned. All right, so I'm having a little bit of, I'm not really having trouble, but I kind of figured because these are N52s, they're pretty powerful. So I use the film here to find the halfway mark. Then I take my marker here and kind of do it, and then I use my magnet field detector. There's north, but unless I push these down really hard, they automatically spin. It'll automatically spin because north attracts south and vice versa. So I think because I made the holes for these a nice tight fit, I should be okay. But I'm a little nervous because I'm afraid it's going to jump up there and smash into each other. I should actually put a piece of wood in between that or something to stop it. Yeah, that's what I should do. I think it's far enough apart, but when I first placed this one down, I placed it like it is now, and it spun so fast I could barely see it. But then when I checked it, I realized that it had spun to the south side. Because, you know, north, south, north, south. But this is north and north. This will be south and south. I don't think it's really going to matter. Like I said, I've never made rotors out of sphere magnets before, so this is all new territory for me. In theory, it should work no matter how I do it, but my my circuits are set up in such a way, I believe, that I need to have it north, south, north, south. So let me try getting a couple more in there. I'm afraid that once I put them in there and I put this guy on here, they may spin irregardless of, maybe not, because they are kind of tight. Yeah, that is pretty tight. So all I need is to have these things smash on me, north, north. Yeah, it's a nice tight fit. And I didn't use the, what's it called? I didn't use this thing to carve out the edge there, because this is the part that laid flat on the bed. A deburring tool, there you go. All right, so let me try and get the other two guys in there. Hopefully I won't smash my fingers. Stay tuned. All right, guys, so really quick before I get this thing together, I've had a couple of requests that want to see the magnetic field. So these are the 4 1-inch N52 sphere magnets, and here's magnetic film. So let me show you what it looks like. You can see, oh, it's better when I lay it down. You can see that it goes all the way around. I don't know if you guys can see that. Yeah, you can see that. It goes all the way around, so the magnetic field is connecting all the way around, which is kind of cool. I don't know which side is better. I think this side's better. I don't know. Which side do you use for magnetic film? Do you use the shiny side up or the muted side up? Anyway, pretty cool. So before I put this, I'm working on a side project where I'm going to that coil that I destroyed when I when I blew up that one rotor where is it? It's on the floor over there. I destroyed that coil, and I'm going to encase it in resin. Here, I'll show you in a second. Stay tuned. All right, so here it is. Oops, let me get this back a little bit. So here's the coil. So I fixed it. I glued it all together. So it still works. It works great. But I've taped off these guys. I put spacers here. I 3D printed a mold. And this slides right in there like that. And you can see I've got equal space all the way around. I've got mold release. I'm going to seal that like that. Then I 3D printed a funnel. And I'll put that down in there and I'll pour the resin in there using this guy here. It should work okay. The only thing I got to worry about is getting enough mold release in here. Now, I've poured inside of 3D prints before resin and they didn't leak. So I'm praying that this one is okay. What I should probably do though, is maybe paint the inside corners with resin. And I put a little lip on there. And I'll probably hot glue that because I know hot glue works. Anyway, that's a side project. Stay tuned. All right, so far so good. There's the coil in the mold. It's not leaking. These towels are just for support. Yeah, that funnel that I made was, the throat was way too small. So I just ended up pouring it on the edges here, and hopefully it'll be all right. I'm hoping that I didn't get it inside the actual terminals. But it's still bubbling up, so I still have some more resin here. It's still bubbling up. I'm waiting for it to, it'll bubble up for a few minutes and then go down because I had those little blocks in there. But I think it's going to be okay. We will know by tomorrow morning. There we go. Give you guys an idea. Again, that was the coil that exploded. So let's get back to this guy, because this guy works out really good. Let me show you. Got the bearings in there, and these are press fit, and it's a perfect print. There's no wobble or anything in it. Look at that thing go, huh? These are good bearings. They're supposed to be ceramic, but I don't think they really are. I think that's just a marketing lie. Although they do tend to really spin for quite a while. Little spin zen. Anyway, I got to get that guy into that stand. But I'm still kind of nursing this guy, so stay tuned. All right, so it worked. This is the coil. I put the resin in. But you can see where I made some mistakes. First mistake is these supports here that helped me to keep it. Oh, and it worked really good with the PLA, with the lubricant release or the mold release. It worked really good. It came right off. There was no problem. You can see there was no, but I had put these braces in here to hold it at a certain distance so it would be equal all the way around. What I should have done was made it in two pieces so that the resin could flow. First mistake. Second mistake was I didn't, you can see this has no resin on it. This has got like about 1 millimeter. I just didn't make the mold big enough. But it did work. Or you can see here, it didn't fill up the whole thing because it was slowly making its way past these support pieces. But it's good and hard, and nothing's going to happen to this coil now, no matter what. I checked it. It's got continuity. Yeah, and I was really surprised because the terminal still works. I thought maybe it would get gunked up, but the tape worked. And then I've got, there's resin inside that hole that I could drill it out, but it's good. It's good. Anyway, stay tuned. All right. So I've got it in there. Let me get you guys over here. Let me bring this down a little bit so we can get a better shot at it. There we go. And I've got it hooked up to my coil, my bifiler, which is hooked up to the dual JL94 circuit. So let's get it going here. Yeah, as I suspected, that is one hell of a rotor. 11.8 volts. Whoa, there's one hell of a wind coming off of that. So it's spinning more on the bearings on the pole than the pole is spinning on the bearings in the housing. But you can hear it. It's flying, and I'm getting solid output over here. Let me show you. I'm getting absolutely solid output. No flickering, no nothing. That thing is flying. So what I want to do now is, and this is really nothing up here. I can actually stop this. It just adds to it, and it's floating. It's on the maglev. There's the opposing magnets down there. Yeah, that was working freaking great. Thank you, Total Element. Yeah, that thing is working great. All right, what I want to do though is I want to hook up 2 coils on either side, run the dual circuits into the run line on each of the coils, run the output to my where is it? My super cap bank, and get it charged up, and then run the whole thing off the super cap. So let me shut this down. Yeah, that thing runs fantastic. Holy mackerel. I didn't think it was going to run that good. Yeah, there's no wobble, no nothing. Ouch, ow, 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 ow. Yeah, so these are sphere magnets. And of course, they're facing out in opposite poles. So north, south, north, south. Because I didn't glue this together, because it's screwed in, and the screws are underneath here, I could change that and turn it into like a super pole where I have north, south, north, south, south, north, north, have the 2 like poles facing each other on each of these, which would make this like a super pole. It would probably run great. I'm going to try different experiments with that, so stay tuned. All right, guys, so I'm still going to work with this guy some more because I want to do some more experiments with this particular rotor the way it's set up. But I went and 3D printed a different rotor, one that should be a little bit more aerodynamic, or at the very least, it looks pretty cool. It's got like these little spaceship things. And then I was looking at it thinking, and I got a comment from a couple of people saying it may not be as aerodynamic as you hope. So what I did was I printed these like sleeves that go over the outside of it, which that makes it more aerodynamic. So now, like that. So I put these on here like this. Of course, I'd have to glue them. But I'm going to first, yeah, so it would look like that, which kind of looks cool. But first, I'm going to just try the sphere magnets that I got from Total Element. Thank you, guys. I'm going to try it in here just to see. And what I'll do is I'll run this at a certain voltage, like maybe 10 volts exactly. And I'll put a tack. I either put a tack here or a tack on the outside here. I've got a tachometer. It's got those little silver strips that you peel off. Probably put it. I don't want to put it on the shaft because the shaft doesn't. The shaft spins independently. It spins inside these bearings here and inside these bearings here. So I can hold the shaft still, and you can see I've got two rotors on here. This one's going one way, so it doesn't, the shaft, I can't put the tack on there. I'd have to put it probably right here. I'll try it here, and then I'll try it out here on the outside, and we'll see what we can get. And then I'll put this guy together, put it on there, and we'll see if it makes any difference. And then I'll also do one, oops, I'll also do one with these guys, which is kind of cool. So the air should come up over it like that, and because it'll be shaped like a drop, this one will be down here. We'll have much more of an aerodynamic flow. All right. Let me find that other one. It's on the floor somewhere. Damn, I always lose shit. All right, stay tuned. All right, guys. So I've got the reflective sticker right on here. And I'm going to set, I have the distance set for the coil. And if I turn on the power supply, it's set at 10 volts or 10.1 volts. Let's see what we got here. 1,000 RPM, 1,300, 1,400, 1,600, 2,000, 2,100, 2,100. Oops, yeah. Yeah, there it is. 2,162. So now I'll take this guy apart and I'm going to put this guy together. I'm not going to touch the power supply. I mean, I'm going to have to move this though, because I realize that when I come on, stop. This wing here is probably going to hit the coil, but that's all right. I'll keep it the same distance. It's about 5 millimeters. So let me do all that, and then I'll bring you guys back. Stay tuned. All right, so I was able to transfer the spheres from, where is it? From this rotor to this rotor. And those are N52s. So if they get stuck together, I literally cannot pull them apart, even though they're spheres. I had to put one in a vise, and then, or use my my magnet splitter that I got from Total Element. They're N52s, and I figured out the secret to placing any magnets, whether they're spheres or cubes, into a rotor like this, and I put the reflective tape on there, is to lay it on a sheet of metal. I use my cast iron table from my bandsaw or my drill press. Lay it on there. When you put the magnets in, they stay put. They don't want to spin, or they don't want to shoot out and hit each other. So let me fire this guy up. Still the same thing, 10 volts. Let's see what we got. 1,100, 1200, still 10.1 volts, 1300, I don't know what that sound is. It's really weird. I can feel the wind coming from this rotor. I couldn't feel it from the other rotor because of those winglets on there. 1800. What did I get before? 2160, right? Oh, something's wrong. 1700. Guess a couple of commenters were right. No, something's wrong. I think I got to change the battery in this guy. I think the battery in this tach meter, there we are, 1900. No, something's wrong. Pull it back. Yeah, that's going faster than 800 RPM. Let me change the battery and come back and try it again. Yeah, now I'm not getting anything. Let me try my other meter. I have another one. Oh, that one doesn't have any batteries in it. 1900. All right, well, it appears to be going slower, and I've also noticed that it's not spinning the shaft as much. I mean, I still have this maglev, and I put this rotor, this little guy on top, but just like I did the other one, and you can see that guy down there, he's barely spinning. So it's using all the bearings. So this is 1900 RPM, so that's a little bit slower than the other one, than just the ball. So some of you guys were right. Let's see what happens now when I put, let's turn this off. Let's see what happens when I put these guys on there. I think what I'm going to do though is change the battery and try it again, because the battery I had in here wasn't, it was like 8.4 volts in this 9-volt battery. And I'm going to replace the sticker because it was at an angle. I don't think that has anything to do with anything, but let me bring you guys back after that. All right, so I changed the batteries and redid the placement of the reflector, and it was still the same, about 1900. So 1900 versus 2160 for this guy, and that's at 10.1 volts with a counter weight up top in the maglev, the same spacing, about 5 millimeters, same coil, same everything. So I guess these winglets are causing too much vertices, probably on the tip here and probably on the end here and probably on each face. So now I'm going to see if I can eliminate those with these guys right here. See if you can see that. With these guys, I'll have to glue them on. I don't really want to glue them on because once I glue them on, I mean, I suppose I could use hot glue, but hot glue has a tendency to be a pain in the ass. I mean, I love hot glue, but all right, so let me get those on and sit and see what else. It's also going to add a little bit of weight. Not much. These things are really light. They're made out of PLA, and they would go something like this on the top and underneath. So you'd have one up there and one down there, which should cut through the air more. But I have a feeling it probably won't. I think you guys are right. the balls themselves, the simple ball geometry here is pretty good the way it is. But that's what the fun of all this is. I love 3D printing, and I love playing with rotors and magnets. Anyway, yeah. Let's get them attached, and I'll bring you guys back. Stay tuned. All right, so I got them on. I have a sneaking suspicion, though, they're going to come flying off. And if they do, it's no big deal. It's not like a magnet flying around. I was able to use hot glue on the bottom ones. I should have used hot glue on the top ones, but I used crazy glue. Let's see what we got here. Oh, yep, one of them flew off. All right, I had a feeling that was going to happen. I don't know if that was one of the ones that had the hot glue. No, that was a crazy glue one. The hot glue worked much better. Of course, now it's out of balance. All right, let me fix this. Stay tuned. All right, so I can't find the other one, but I put it. Let me slow this down. So I've got them all on except for this one, and I decided to test it anyway, and it was the same, which is kind of weird. I don't think just one is going to upset it unless it's because it's a balance thing, but I don't think so because it wasn't wobbling. But yeah, it was the same. It was like 1900. So I guess this guy by itself is right on, is good. All right, so the next thing I'm going to do is, I still kind of like this setup, but I think I'm going to go back to this guy. And what I want to do is I want to set up my bridge rectifier, get my supercat bank, see if I can charge it up running just one of the JL94 circuits into this guy, the other side out into the bridge rectifier, and see what happens. Or I may even try this guy, a guy that I casted with resin. This was the one that exploded when I wasn't paying attention and slid it out and it caught the rotor. But it's good now. All right, so I think that's going to be it for now, guys. Thanks for checking in. Ciao.